All right, so 9.3 is called hyperbolas. Hyperbolas are the last of the four conics, including circles, that we're going to talk about in chapter 9. Also in this section, we're going to learn how to identify a conic from its equation. Like if I gave you a full equation, if you could tell me that it's a circle, a hyperbola, ellipse, or a parabola. And then also we're going to learn what happens to these conics if we rotate them. So every single one that we've done has an axis that's either vertical or horizontal. And so we're going to figure out what would happen if we rotated that around, but we'll save that for part 2. So today we're going to focus on those first 2 parts. So a hyperbola, which you should remember from Algebra 2, is the set of all points x, y in a plane. The difference of whose distance from 2 distinctive points is the foci, the points that is the foci, is a positive constant. So basically what's happening here is instead of them being circular or ellipse where it would be oval shaped connecting those points, you're turning those curves and pointing them outwards, which kind of creates the shape of those 2 parabolas. So 2 parabolas turned and facing each other. So in this one, it's just showing you that the distance between the point on the curve and the actual focus, they actually forms that right triangle, which we're going to use in just a moment to get to that relationship. Okay, but basically you just need to know the shape from here. The parts of a hyperbola, so some vocab terms that are different with hyperbola than any of the other conics. The graph of the hyperbola has 2 distinct parts called the branches. So those curves that look like parabolas are actually called branches. The line through 2 foci intersect the hyperbola at 2 points called the vertices. So you still have a vertex with a hyperbola like you did for an ellipse. The difference is that's where the point changes direction just like a parabola does. It's also along that major axis, which has a different term. In hyperbolas, we call that the transverse axis. So the axis that makes it vertical, if it's a vertical one, or horizontal, if it's horizontal, is called the transverse axis. So transverse is kind of like the major axis if we compare it to ellipses. And then the midpoint of the transverse axis is the center of the hyperbola. So you still have a center like you did with an ellipse, except this time it's in between the 2 parabolas. And again, transverse is the axis that this one runs. So in this case, this is vertical. My vertical axis would be my transverse axis. Here goes into a little bit more into depth of the standard form of a horizontal and a vertical. So if I look at the horizontal one, it's horizontal because it points right and left. Okay, so this is considered to be a horizontal hyperbola. The transverse axis is the horizontal axis. So transverse is kind of like your major one, like I just said. The other axis, which we used to call the minor axis, is called a conjugate axis with a hyperbola. You still have a center, which we just mentioned. It's just halfway between the vertices and halfway between the foci and halfway between the co-vertices. You still have an A and a B and a C. So the A is still the distance from the center to the vertex in either direction. The C is still the distance from the center to the focus in both directions. And the B is still the distance from the center to the co-vertex. So all that is the same for hyperbolas as it was for ellipses. The vertex, the center, and the focus all lie on the the center lies on both, but the vertices and the foci both still lie on the transverse axis, and the co-vertices lie on the conjugate axis. And then you have these, which are asymptotes, which hopefully we remember asymptotes. Last time we did them was the rational functions, right? The asymptotes provide your guideline for how narrow or wide your curves or your branches are. So the wider apart the asymptotes are, the wider my curve is, or my branch. If it's narrow, if it makes a little bit of flatter x, then it's going to be a more steep curve. You want your curves to get as close to without touching those asymptotes as possible.
Do you have no directrix?
No. Yeah, there's no directrix. So there's only the directrix with the parabola. Okay, then if I turn it so that it's vertical, now same pattern. Now my branches face up and down, still same center, Vertices are still the A distance away. Foci is still the same C distance away from the center, and those both lie now on the vertical axis, which is my transverse axis. And then the co-vertices lie on now the horizontal axis, or my conjugate axis. And again, there's still your asymptotes, which is determining how narrow or wide your branches go. Okay, if it has a shifted center, so those both that we looked at just had my center was at 0, 0. If it shifts, then the only thing that changes really in my equation is the top number. Okay, but basically it just shifts it over. Everything else is still the same. This would still be A distance away. This would still be C distance away. And you don't see it on this axis, but it would probably be about there would be the B distance away. So everything just gets shifted, whether it's horizontal or vertical. And here are my equations. So the top one is the standard form of a hyperbola with a center that is not at 0, 0, like HK. H still goes with the X. K still goes with the Y. It still represents the center. And this is if it's at the origin. Notice there's no H and K. That's the only difference. So if I compare this to the equation for an ellipse, what could you tell me is different? There's a minus sign. So the minus is obviously the biggest difference. Okay. What do you notice about the location of the A? It's always first. Okay. So where the A is biggest with an ellipse, A is first with a hyperbola. So first major difference is there's a minus between. Second major difference is that A is always first, and that's how you determine if it's supposed to be vertical or horizontal. So if the first letter, which is always going to be positive, you'd always switch it so the negative comes second. If the first letter is X, then it's horizontal. If the first letter is Y, then it's vertical. Whatever's under that first one is always your A. Whatever's under the second one is your B. The third difference is the equation to find the relationship between C, A, and B. So this time C squared is equal to A squared plus B squared. With the ellipse, it's minus. And then note at the bottom it says the length of the transverse axis is 2A. Remember, transverse is just like major. And the length of the conjugate is 2B, which is just like minor. So again, instead of memorizing stuff, I would say, obviously you need to memorize these formulas, but you want to learn the relationship between them instead of trying to fill out a chart, that kind of thing. So this one says find the standard form of the equation of the hyperbola with foci negative 1, 2, and 5, 2, and vertices 0, 2, and 4, 2. So the first thing I would do is graph it. So negative 1, 2, 5, 2. These are my foci. 0, 2, and 4, 2. Those are my vertices. So what do you know already about this hyperbola? What's the most obvious thing? It's horizontal. Okay, so if it's horizontal, because that's where the vertices or the foci would be, then I know it's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. What else can you tell me? How would I find my center? How do I find the center? It's halfway between the vertices or the foci, right? Doesn't matter. I could do the midpoint formula for these, either one of those, or I could simply count it. Okay, if I went from foci to foci, that's the difference of 6. Halfway between it would be 3 in either direction, which is information I'm going to need to know because that 3 is my C. The A is the distance from the center to the vertices, so I know A is 2. And the center, which is 2, 2, is my H and my K. With me so far? So I can already say x minus 2 squared over a squared, which is 4, minus y minus k squared, which is 2 squared, over the only thing I don't know, which is b, equals 1. And what do we say the relationship between a, b, and c is?
C squared equals a squared plus b squared.
Good. So if 3 squared equals 2 squared plus b squared, b squared is 5. So you don't even need to know what b is. B would be the square root of 5. But when I plug it back into my equation, it's b. Sometimes a is going to be bigger than b. Sometimes b is going to be bigger than a. This is different from ellipses. Ellipses, a has to be bigger. Think about your formula. C squared equals a squared minus b squared for an ellipse. So it has to be bigger because it can't be negative. But for a hyperbola, it does not matter. Questions on that one? All right, asymptotes. So we said the asymptotes are the lines that are going to create how wide or narrow my branches are. Each hyperbola has 2 asymptotes that intersect at the center of the hyperbola. The asymptotes pass through the corners of a rectangle of dimension 2a by 2b with its center at hk. So if I look closer at this diagram, here's my center right at hk in the middle here. This is a horizontal one, so I would have gone to the right A to the left A, and I would have gone up B and down B. And what happens is I can actually go out and draw myself a little rectangle based on those distances. And the corners of that rectangle are where my asymptotes pass through. So you can either get the equation of the line that is your asymptote, draw the equation of the line and where it crisscrosses make your branches, or you can count out your A up or down, whichever direction it's supposed to go, and your B, make yourself a little rectangle and draw yourself your asymptote. Now this one is almost like a square, okay, which is totally fine. Again, it can be the same. A and B can be the same measurement. It would make almost like a square in the middle there. All right, so the equations of the asymptotes are found based on whether it's a horizontal, transverse, or vertical. So if it's horizontal, then my equation is y equals k plus and minus b over a, so therein lies the difference, times x minus h. And if it's vertical, then my equation is y equals k plus and minus a over b times x minus h. So the h always goes with the x. The k goes out by itself. It would go on the side with the y, but these are lines, so it gets it into a y equals format. The difference is that slope. The slope is formed b over a if it's horizontal, a over b if it's vertical. So you'll get questions given to you where it gives you information about the asymptotes and you have to figure out how to graph it, or you'll maybe get the information about the actual hyperbola and you'll have to find the equation of the asymptote. Sketch the hyperbola whose equation is 4x squared minus y squared equals 16. So what do you notice about this first? Good. It's not set equal to 1. So the first thing I have to do is divide everything by 16. So I'd get x squared over 4 minus y squared over 16 equals 1. Now it's in standard form. What can you tell me about this just by looking at that? It's horizontal because the x comes first. What else do you know? Good. Centers at the origin, centers at 0, 0. What else? Good. A squared is 4, which means A is 2. B squared is 16, which means B is 4. So centers at 0, 0. It's horizontal, so I'm counting right and left the 2. And up and down the 4, which is the B. And then I can make my little box. And the corners are where my asymptotes are going to go through. And I want to make it as close to without touching my asymptotes as I can get. So you want to fill that space.
Can you, I'm sorry, explain how you got the point for the asymptotes again?
So once you're, so if it's horizontal, I'm going right and left the A. So I go out, right, left the A, up, down the B, and then form your little box. So the same distance out and up and down as your, twice the A, twice the B. And then the corners of that rectangle are where your asymptotes are going to pass through.
But when you're graphing, you always have to graph the foci, right? You have to draw them.
If it says to do it, yeah. But if it was just like that last one just said to graph it, you don't need it. So put the equation in standard form, find the asymptotes, and then sketch the hyperbola given by 4x squared minus 3y squared plus 8x plus 16 equals 0. What are you going to have to do first? Complete the square. Okay, it's not going anywhere. So group it together. This time, there's only a y squared. There's no y, which means that is a completed square. I don't have to do anything with the y yet. I'm going to group the x's, take out the 4. A couple of you made mistakes taking out that second term. Don't forget to take it off that 8 too. And then take the 2, divide it by 2, it's 1, square it, it's 1, and don't forget to multiply by the 4. So I get 4x plus 1 squared minus 3y squared equals negative 16 plus 4, which is negative 12. Now what? Good. Divide by negative 12. So why is that negative important? Good. It actually changes which one is negative. So you can't determine which one is the transverse axis until you get it in standard form. If you look here, that negative 3, that negative actually should come out front. That whole fraction is negative, which means this is a y squared over 4 minus x plus 1 squared over 3, which means this is now a vertical hyperbola. Does that make sense? Okay, so now tell me what else you know about your equation. Or your graph. Good. Center's at negative 1, 0. What's a squared?
4.
Which means a is 2. What's b squared? Which means b is square root 3. And for graphing purposes, I'm going to approximate that, right? It's pretty close to square root of 4 or 2. So I'm going to say this is like maybe 1.8, something like that, 1.7, 1.8. And now I'm going to graph. So center, negative 1, 0. We said it's vertical, so I'm counting to the right 2 places. Nope, sorry, up 2 places. Down 2 places. Right 1.8, left 1.8. Draw your little box. Asymptotes going through the corners. Branches going off your vertices close to without touching your asymptotes. Now we've got I didn't do the asymptotes, okay? So when it says find the asymptotes, we know this is vertical, which means it's a y equals k plus and minus. Vertical is a over b, x minus h. And then from here, y stays as y. My k is the y corner of my vertex, which technically is 0, so I don't even need it. Plus or minus the a, which is 2. B is root 3. And then x minus h. H was negative 1, so this becomes a plus 1. And you can't leave a irrational number in the denominator. So I do 2 root 3 over 3. That's my asymptote. Isabella. The K is 0. It's the Y coordinate of your center. So let's just say I had used this to graph instead of the little box. This would have been Y equals plus and minus. I would say 2 over 1.8 x plus 1. So I would go to the 1 on the x. That's just like my 0, negative 1 would be here. And then I would go up 2 and over 1.8. Up 2 and over 1.8. And that's where the slope comes from. And then I would go negative to 1.8, which means down 2 and to the right 1.8. Down 2 and to the right 1.8. So if you have the equation, you can use either one you want to graph your asymptote. But obviously, if you have the A and the B, in my opinion, it's a lot easier to do the box than it is to do estimating of a 1.8, okay, as a slope. But you can use either one. All right, example 4 says, find the standard form of the equation of a hyperbola having vertices 3, negative 5, 3, 1, and having asymptotes of y equals 2x minus 8 and y equals negative 2x plus 4. So first piece of information is that the vertices are 3, negative 5, 1, 2, 3, 1, 2, 3, 4, 5, and 3, 1. Which already tells you what? Vertical. So it's a y minus k squared over a squared minus x minus h squared over b squared equals 1. So these are my vertices. And you have your asymptotes, which you can either draw or you can use them to get the information you need out of them before you even draw them. So if I look at these are not set in standard asymptote format that we had, which was, this is a negative, y equals k plus and minus. This is vertical, so it should be a over b times x minus h. The major difference is that x has the number attached to it, so I would take it out. This would be 2 times x minus 4 and negative 2 times x minus 2. So the a over b is flush against that parentheses, which makes sense. One is positive and one is negative, right? Because that's the way it should be. And it doesn't matter which one you grab. You can say that 2 or negative 2 equals a over b. Do I know either a or b yet? How could I figure it out? Good. So the center of my vertices, so I can either use the points to find my midpoint or I can count it out on my graph. So the distance between negative 5 and 1 is 6. Half of that is 3, which means A is 3. 1, 2, 3. There's my center, which is 3, negative 2. Now I have my H and my K. And I have the top part of my A over B. So 2 equals 3 over B. Cross multiply that, I get 2B equals 3, and B equals 3 over 2. And now I have all the information I need for my equation. I have my H, I have my K, I have my A, I have my B. And I know that the transverse is vertical. So it is y minus a negative 2 becomes plus 2 squared over a squared. A is 3, so this is 9. Minus x minus the h, which is 3 squared over the b squared. 3 halves squared would be 9/4 equals 1. Can you leave a fraction in a denominator? No. So dividing by 9/4 is the same thing as what? Right. So this becomes y plus 2 squared over 9 minus 4x minus 3 over 9 equals 1. So the dividing by is the same thing as multiplying by 4/9, so you can just flip it.
Minus 3 not squared.
Oh, no, sorry, it should be squared. It's actually something that some of you did yesterday. On your quiz, some people squared both parts of the parabolas or forgot to square.
You got the center from doing midpoint?
The midpoint of the two vertices. Yep. So the center is halfway between the vertices or the foci or the co-vertices. Whichever pair you have, the center is the midpoint of, or the midway between. So if you had a graph and you're really careful and accurate, you could literally just count it. If you don't have a graph, you could just use the midpoint formula. So the only thing I needed out of those asymptotes, because I'm not graphing, was what the A over B was this time. If I had used them to graph, then I would have plotted those points as though they're the lines, right? That's y equals mx plus b format. I would have just graphed them. Questions on this one?
Why did you make 2 equals A over B and not negative 2?
It doesn't matter because you're squaring it, right? You're getting your b and you're going to be squaring it either way. Does that make sense? Okay. Whether you were getting your a out of it or your b out of it, it wouldn't matter. I could have set them both equal to -2. I would have gotten -3/2, and then I would have squared it either way. All right, so eccentricity of a hyperbola. The eccentricity of a hyperbola is the same as it was for an ellipse, c over a. This time, e is always bigger than 1. So with an ellipse, it was in between 0 and 1. With a hyperbola, it's going to be bigger than 1 because c is always bigger than a. C is the sum of a squared and b squared, right? So it has to be bigger. When the eccentricity is large, the branches are nearly flat, so they're widened out. And when it's smaller or closer to 1, they're more pointed. It's more closer to a little skinny v for you. So again, you might given this in information to get the equation or to get the formula, to graph it, or you might just be asked to find the eccentricity and it should match with what you got. So something like the ones we just drew, which were a little bit wider, I would expect to have a bigger e. If it was narrow, I would expect it to be closer to 1. Okay, so the last part that we're going to cover today is this. General equations of conics. So you can look at an equation, and it must be in standard form. So they're all going to be on one side. And you want it to be in this order. So the A is on the x squared. The B is on the xy coordinate. The C is on the y squared. The D is on the x, the E is on the y, and the F is the constant, although you don't even need those, okay? What you're really looking for is the A and the C. The A is attached to the x. The C is attached to the y. If those two numbers are equal, then without mapping anything out, you would know that your conic is a circle. If the product of those two is 0, then it's a parabola. Because think about it, one of your squareds isn't going to have a number, isn't going to be there, which means the A would be 0 or the B or the C would be 0. If it's bigger than 1, it's an ellipse, and if it's if it's bigger than 0, it's an ellipse. So if it's positive, which makes sense, ellipse, we put a plus in between. And if it's less than 0, which means it's negative, it's a hyperbola. Again, should make sense because there would be a minus between them. So you are going to get questions in which you don't have to do any other work than to just classify what type of conic it is. So for example, A, what's the A? Oops, what did I say? 4. What's the C? 0. There's no y squared, right? Which tells you this is a parabola. For B, the A is what? 4. The C is? -1, which product is -4, which tells you it's a hyperbola. C, A is 2, C is 4, which tells you this is the product would be positive, right? Which would be what? An ellipse. And the last one, A is 2 and C is 2, which tells you circle because they're the same. Easy stuff, right? So even if you didn't remember like the exact, think about what should be happening, right? If a parabola, there's only going to be one squared term, whether it's the x or the y. If it's a hyperbola, one of them is going to be positive, one's going to be negative, because think about your equation. If it's an ellipse, they're both going to be positive, or they're both going to be negative. And if it's a circle, they're both going to be the same. Questions on anything we talked about today?